All right, guys, let's do a couple of these problems from the worksheet. I'm gonna work them out. Hopefully you understand it a little more from the notes that I previously gave you. So let's do a couple of the odd problems. Just remember that we are using the properties. So really quickly, just verbally, remember if you are multiplying within a log, like for example in number 1, we can turn it into addition. Okay, if you are dividing within a log, you can turn this into subtraction. Okay, powers turn into multiplication in front of the log, and that's pretty much it. All right, and it also works in reverse. So subtraction can turn into division, multiplication can turn back addition can turn back into multiplication. And if you have multiplication in front, you could turn it back to exponent. All right, so let's do a couple of these odds. Let's do number 1. So number 1, what you'll notice is we have multiplication. This is 3 times x. So if you want, it really looks like this. And we know to expand, we want to create more logs. We have one log, we want to create more when it says expand. So multiplication actually turns into addition. So I can write the multiplication into 2 separate logs. And I can turn it into addition. So that's how you do that one. Number 3. Again, I'm going to rewrite this so you can see the multiplication. It's really 3 times h to the third. So we are going to expand using the multiplication property, which says I can now turn this into addition of 2 logs. Okay. And then we can't forget this last property. If you have an exponent, we can put the exponent in front as multiplication. So this guy can now go and multiply in front of the log. So my final answer would be log base 9, 3 plus 3 times log base 9 of h. Okay. All right. Let's go ahead and do the next problem. Let's do 5, just so we can get a little more practice in this one. So in 5, what you have to understand is this power actually goes to both 5 and t. So if I was writing this out, it would be log 5x plus 2, okay, times t, and he also gets x plus 2 as his power. So recall, we can turn multiplication, and multiplication can turn into addition. So it looks like this. Log 5 to the power of x plus 2 plus log 5 t to the x plus 2. And we also know that when you have a power, powers can get multiplied in front. So this guy can now get multiplied in front, and so can this guy. So we're going to have x plus 2 multiplying in front, log 5 plus x plus 2 log t. Okay, and that's your final answer there. All right, so let's do a couple of condensing. Condensing just means we're going to do the reverse. If we have addition, it turns into multiplication. If we have subtraction, it turns into division And if we have anything multiplying in front, it turns back into an exponent. All right. So let's try 7. We have addition. So I can turn these two logs, since the logs match, I can turn them into one log. And it's going to be 6 times 2 now inside the log. So log base 4, and then 6 times 2 is 12. Okay, pretty simple stuff. Let's do we're going to jump down to number 11. All right, so they all have the same log base. That's one of the rules. In order to use these properties, they have to have the same log base. So since they all have the same log base, I'm going to go ahead and turn this addition into multiplication. So these two will combine into log base 3, 6 times y. And then division, I'm going to divide by 2. Okay, so I'd throw this in parentheses just so it looks a little nicer, but that would be your final answer. And we're good to go there. All right, let's jump to number 13. 13, we're going to use properties and simplify it if we can. So let's go ahead and do these properties. So the first property I see here, simplify, means we want to basically condense it and then do the math that we can. So addition turns into multiplication. So these two logs turn to log base 4, and we're going to go 40 times 25.6. Okay. If you multiply this into your calculator, you get log base 4, and it's going to give me 1,024. So now we ask ourselves, can I actually do this math with a calculator, or maybe even without a calculator? So what this is asking is 4 to the what power is equal to 1,024. Okay, so if you do this correctly, the power you should get is this should equal to 5. So this would be your answer, because 4 to the 5th power gives me 1,024, and that's a question we should be asking. All right, let's go ahead and jump to 15. So 15, again, they're all log bases. Let's go ahead and do this multiplication here because it's addition. So we're essentially going to do log base 2 of 60 times 12.8. And then whatever answer we get, because of subtraction, we're going to divide by 6. Okay? So let's do this math. Log base 2, 60 times 128 is 768. And then we're going to divide that by 6. So we get log base 2 of 128. Okay? So what we're asking is 2 to the what power gives me 128. So if you do this math correctly, it's actually going to be this. So log base 2 of 128 is actually equal to 7. Okay? Because it's 2 to the 7th power gives me 128. Alrighty. We'll go ahead. I don't want you to try that one today. But let's skip down to 19. In other words, we're just going to try to solve for y. Okay? So we want to isolate our y. Okay? But we can't get to the y until we take care of this power of 2. And we can't get to this power of 2 until this whole term here is isolated. So I got to get everything on the other side of the equal sign, but this whole thing that's raised to the power of 2, or in other words, my base. I got to isolate my base. So the first thing I want to do is subtract 10. And it's 3y to the second equals negative 28. All right, once we have that, we can now get to the y as long as we get rid of the power of 2. And you should remember the things that get rid of power of 2 is a square root. So we're going to square root both sides. So this can cancel out with that. And now we have this equation, 3y equals to the square root of negative 28. And now we're doing a little bit of review here. This whole problem is review from pretty much Im3. But we now need to solve for y. And before we do that, you have to remember that this negative under the square root cannot happen. We have to turn this negative into imaginary numbers, or in other words, this negative turns into an I. So it looks like this. 3y equals I, and now the negative 28 turns into 28. Okay, and what I'm going to do now is I want to, before I finish this problem off, I want to figure out, can I simplify the square root of 28, which you can. So the square root of 28, I'm going to do that work here. And I like to do the tree method. 7 times 4, this turns into 2 times 2. All I'm doing here is simplifying the radical. Remember, we want a pair. So the square root of 28, because we have a pair, the pair comes out of the radical. The non-pair, which is only 7, stays inside the radical. So the square root of 28 turns into this. 2 radical 7. Okay, and then we cannot forget that on the outside already we had the I, so I'm going to put the I right after the 2. So it's really 2i, and this is always plus minus. Okay, so my problem now looks like this. 3y equals to plus or minus 2i radical 7. And then the last thing I want to do is I need to solve for y, so I'm going to divide both sides by 3. Okay, so we are done. Y is equal to plus or minus 2i radical 7, all divided by 3. Again, this problem is review from Im3. Just thought I'd throw it in there to see if you can figure it out. All right, we'll stop there. Hopefully this helps. Have a good one.